I come from Ireland. I was always keen on science at school and wanted to be a researcher, but I made a decision that I needed a professional qualification, and so I went to veterinary college. Went to veterinary college in Edinburgh. When I was in veterinary college, I got interested in pathology and then spent a year as a pathologist in the medical school in Edinburgh. I found that cutting up dead bodies was rather boring, but I got interested in immunology. So then I went and did my PhD in immunology and eventually got a faculty position in Canada teaching immunology. The problem there was that I'd done my PhD on mouse immunology, and I was required to teach veterinary students about cattle immunology and dog immunology and cat immunology, and I knew very little about that. So I decided to bring it all together and write a book. And so I wrote a book on veterinary immunology that has been published ever since. And my research has focused essentially on immunity, vaccines, immunological diseases of animals, mainly mammals, but for many years I also worked on birds because vaccines work just as well in birds as they do in mammals. So I'm continuing to work on immunology and on vaccines.
Okay. So birds have been migrating for millennia. Why are we more concerned about bird transmitting things nowadays than they have in the millions of years they've been here?
Well, I think that reflects the more we know about things, the more we recognize that there can be problems. Just to give you an example, our colleague Sarah Hamer has been trapping mist-netting birds around this community, and she's found that they carry lots of ticks on them, exotic ticks from South America. Now, from one point of view, that's no big deal. If they fall off and there's no partners, then they're not going to grow. But in fact, we've just seen a new tick, the longhorn tick, appear in New Jersey and spread now to 9 different states, which probably was transmitted by migrating birds. So birds can and do bring disease. An even better example, of course, is influenza. Right? Influenza is really a bird virus, and it primarily infects birds that summer in the Arctic. And each fall when they come south, they bring influenza with them. And that influenza can be transmitted sometimes to chickens or other birds. It can even be transmitted to pigs. And from there, it can be transmitted to humans. So influenza is essentially an Arctic virus that is transmitted by migrating birds down to communities here.
But it's been that way for a long time, right?
Yes, we're only realizing that now. That, good example is the great influenza pandemic of 1918, which we now know was probably originated as a bird virus. Yeah.
You know, sometimes scientists dig up dinosaurs and they may put the wrong dinosaur's head on them, and then later on they discover that there was 2 different dinosaurs in that hole. How can science come up with the truth eventually?
Well, that's a tricky one. You're essentially, I think, talking about ancient DNA. One of the factors that we've seen in recent years has been our ability to extract DNA from skeletal remains and characterize it. A good example is the Black Death, which is caused by a bacterium we call Yersinia pestis. And for years, people argued what was the cause of the plague. Well, it turns out that you can excavate human skeletons from plague graves. You can extract DNA from places like the roots of their teeth, and you can sequence that DNA. And it's all chopped up. It's a bit of a mess. But then with computers and artificial intelligence, you can reassemble that DNA. And that has shown, also I think in like 14 different cases now, that there is the plague bacterial DNA in those teeth. So we know that what killed people during the plague was the plague bacillus. A similar example occurred recently in Mexico City, where they found a mass grave, and again they found salmonella DNA in the teeth. So the question then is, how far back can we go? And we're getting better and better and better, but I know that, for example, there was a report of plague in a Stone Age person in the Middle Stone Age from Sweden just recently. And that's getting close to how far back we can go. If we ever get dinosaur DNA, and of course it's conceivable because fossils vary in quality, then we will certainly be able to determine who's who. It becomes essentially the ultimate arbiter. It's one thing to look at skeletons and shapes and anatomy, but when you get down to the molecular level, then it's going to give you a much more precise analysis of what's going on.